Okay, so today we're talking about a new way of graphing, a new system of graphing called polar coordinates. So polar coordinates are quite different than what you're used to graphing in, which is Cartesian or rectangular coordinates. And so the way that this works, so polar coordinates are based on, so instead of calling it the origin, in polar coordinates we call it the pole. So you imagine you're looking down on the top of the Earth, and you're looking at the North Pole, or you're looking up from the bottom, and it's the South Pole. All right, whatever. But so then you got circles that are like latitude lines, right? Latitude lines. And so the pole is what we now call the origin, right? And so rather than x being distance right and left and y being distance up and down to get position, instead we do angle, theta, and this is the standard trig angle, okay? The standard trig angle, which is swept, it doesn't matter. It's standard trig angle swept counterclockwise from the positive x-axis. So that should be very familiar from all your trig, right? Theta equals 0 is the positive x-axis. An angle measure is measured by sweeping counterclockwise from positive x. So once we have an angle, then the next thing we do is, so that terminal side of the angle determines where positive, what we call r is. R being like radius, distance from the pole. Okay, so you can think of it like this. Once we pick this angle theta, right now I've got the angle theta of 2.76. So this is 2.76 radians. And when theta is 2.76 radians, the second coordinate, which is r, or radius, distance from the pole, is measured only along that line, only along that terminal side of the angle. So then 2.76 radians and r equals 4.5 would give you this point right here. But when you list the ordered pair, the conventional way is to put the r first. But you think about theta first, okay? So you think about 2.7, you sweep out the angle first. And then once you've determined the angle, then along the terminal side, that's your direction of r. And so this point right here would be 4.5 and 2.76 radians. What does 2.76 mean? So what does that, you know what 2.76 radians means? What is that? What's the meaning of that number? Okay, so it has to be on the unit circle. So he's saying it has to do with arc length. What arc length is it? What arc length is 2.76 and measured in what? What do you think? Yeah, go ahead.
The radius, since it's 2.76 radians, like the distance, if you drew a circle from your point all the way around
Yep.
the x-axis at 4.5, that arc length of that would be 2.76 times 4.5.
We're at 4.5.
Like the definition of a radian.
Yeah, so radian is, it's the length of this arc, but it's also the length of this arc because it's measured in radius lengths. So this is our current radius. And so if you took 2.76 of those, so 1 is about here, 2 is about here, and so here's about 2.76 of these radius lengths will get you to this terminal side. But it's the same for this down here, right? Because we got a smaller radius. 2.76 of these will take you around the same angle measure. So radians is a number of radius lengths of arc length. It's a number of radius lengths of arc length. That's what radians means. So all these angles that you've memorized, pi over 4. So do that. What's pi over 4? Put that in your calculator. First one to get it, shout it out. 0.7 something, 0.6 something? 785. About 0.785. What does it mean? It means that at pi over 4, which is right here, this arc length is about 78 or 79% of a radius. This is 0.785 radius lengths from there to there, and that makes the angle pi over 4. So pi over 4 is not just the name of this angle, it's actually a number, right? It's a number, it's 0.785, and it's telling you how many radius lengths to sweep from the positive x-axis. So you don't go quite 0.8 of a radius length, and that gets you to this angle, which is exactly pi over 4. So that was a crash course on radians. You don't have to pay me for that. 0.785 radius lengths of arc length. That's what radians are. Radius lengths of arc length swept out by the angle. Yeah. Radius length. So this is how long one radius is. So this would be like 78% of a radius. Lying on the circle, this is how far it is. So this is 0.785 of a radius. Yeah, you're right. Taking the radius, using the radius as a measuring stick along the arc. Yep. Taking that radius and using it as laying up. So if you lay it all the way to here, this is about 1. One radius length is about here, maybe a little bit higher up. Okay, but back to our regularly scheduled program. So 4.5, 2.76 means we do theta of, this is theta of 2.76. And then once we have that direction, 4.5 is right there. So that's the point 4.5, 2.76. Okay, so these negatives on your graph paper and on my screen mean nothing, right? They mean nothing because theta, positive r, can point in any direction from the pole. Positive r can point in any direction from the pole. So even down this way, this is now theta is 3.86. So for an angle measure of 3.86, this is the direction of positive r. The terminal side of the angle always points in the direction of positive r. So can you have negative r? Where would that be? So it would be in the opposite direction from positive. So this, if I have this angle here of, what was it? 3.86, negative 2. Do you see where the, so do you see where the point negative 2 comma 3.86 radians is? See where that would be? You should be looking right there. So the angle takes us this way for positive r, but then if the r is negative 2, then you go back the other way. So this is the point. Negative 2, comma, 3.86 radians. Does it make sense? So positive r can point in any direction. It's not that when you point to the left it's negative, when you point down it's negative. No, first you do the angle, and the angle tells you the direction of positive r, which can be any direction around from the pole. Then once that theta is picked, positive is that way, negative is the other way, directly the opposite way. Okay, any questions? So let's do some practice. So I'm gonna throw some points up. We'll do one at a time. I'll throw some points up, and you're gonna write down what the coordinates are. No, because you're just writing down the coordinates. You're not graphing anything. You can you could use that. Yeah. So you're welcome. You've got two sides of that. You've got 12 different axes. Whenever you need to, you're welcome to. That's just for your use. So you don't have to draw that every time. Make it easy to start with. Okay, here we go. Okay, so here's the first point. You see it over there? So, what's going on? Sorry, this is right. All right, so there's 0. So let's do this one. All right, so this is angle is 0. So the coordinates would be 5, 0, right? So, but again, you think of the 0 first. Think of the angle first, and then the resulting radius at that angle. All right, let's try something over here. So, do you remember your angles? So the key angles would be this one, this one, this one, this one, this one, and this one. So it's like the middle 3 on each quadrant are your key angles. And of course, on the axes are key angles too. So the middle 3 radial lines in each quadrant are the key angles that you have memorized before in pre-calc. So for instance, this one is, what angle is this? You said 5 pi over 6. Remember that? So the coordinates of this point are 2, 5 pi over 6 is this point. 2, 5 pi over 6. Let's try something different here. Okay, do this one. Coordinates of this point. Check with the person next to you. What do you think? Let's write these down as we go. Keep track here. Okay, what angle is this? Pi over 3. So the point would be 4.5, comma, pi over 3. Okay. This one. So angle is, she's asking if it's 4 pi over 3. Question?
So are there 4 different ways you could write each?
So if from 0 to 2 pi there is, but if you let the angle be any angle, then there's, yeah, we're getting there. Yeah, you're right. Yeah. So what's this one? So, but the way I've depicted it here, there's only one way to write this because of the way I'm structuring this, framing this. There's only one way here. So what would it be? 4 pi over 3, comma, -1. Puts us in the, what quadrant is the point? First quadrant. So he's noticing that that same point could be also written as, so if I took off if we just had the point and I took off the angle in the scale, then there's another way to get to that point in the plane, which would be 1 pi over 3. Now, I don't know, because I think of the angle first. Yeah, because I was thinking about it the right way. That's why I did that. But then you have to write it R3. Okay, any questions on the basics here? Let's do one more. This one. So this point right here. Question.
Is there any particular reason that the coordinates are so counterintuitive? Like with it being r theta rather than theta?
Oh, yeah, the convention? I don't know. The alphabetical? I don't know. That's a good question, though. I don't know how that came about. All right, so I want you to write the coordinates as I'm showing you, right? As I'm framing it, you write the coordinates at that point. And check with the person next to you. Okay, everyone good? Got it? Okay. All right, so let's do another exercise. Now I'm going to give you points, and you're going to sketch them. So here's a list of points. I want you to sketch these. So the angle determines the direction of positive r. So say your angle is like this. So for this angle, this is the direction of positive r. Negative r then is the opposite direction from positive r. Look at my illustration. If you have a negative angle, negative angles then determine the direction of positive r. See? So I'm showing negative angles here, right? Negative angles would sweep clockwise. Okay, so how about if I do F? I'll do F. I'll do the last one. Here, we got to F yet? So negative 5, 5, or 6, we're going to, negative angle means sweep clockwise. And 5, 5, or 6 will be where? Oops, sorry. So we're sleeping, this is clockwise, so it's a negative angle. And 5, 5, or 6 is here. And I think then that point is. And so is that the point then? No, it's going to be -2, right? So here's my angle, negative 5, 5, or 6, swept clockwise from the positive x-axis. So that gives you the direction of positive r. So the -2 would be back in the first quadrant. Here's point F. That's for problem F. Is it making sense? Please. You don't have to draw any lines at all. Find the points. The line is purely a visual aid. So yeah, so if you want to draw the line to help you, Yeah, so you could draw just, if you wanted to, you could draw just the positive if you want. Just draw it like that. And then you know that negative's back this way. So you can go back to from there. So this is my line, and the red and the black numbers is purely to help you understand what's going on. The key is can you get the right location of the point? Other questions? Yes, please.
I noticed on GC there you have like 3 elements to the coordinates up at the top. Like it's 0, 2, 5. What is the significance of that 0?
What now? Oh, this is a slider.
Oh, okay.
This is just, I'm just creating a new slider. So that's 200 steps from 0 to 2 pi. Okay, so now I plotted a blue point. So what I want you to do is I want you to write that point in polar coordinates 4 different ways. 4 different ways that you could be defining that point in polar coordinates. Go. Work together. 4 different ways. No, yeah, we'll do some curve sketching. Yeah. Can we talk right after? But it'll be easy to come up with something because we'll just pick the graph. Okay, so for this blue point, so the easy one, the most natural one would be angle measure of 2 pi over 3, and then positive r of 3.5. So that's kind of the most straightforward and natural one. All right, so then what else? And so what angle? So the angle first. So yeah, so the angle that's across in the third quadrant would be 5 pi over 3. And if we're pointing in the direction of 5 pi over 3, then that point would be at negative 3.5. Does it make sense? So 5 pi over 3, let's show that. Five pi over 3 points, no, what am I doing? What's wrong? Here we go. 5 pi over 3 points this way. So starting at the x-axis all the way around into the fourth quadrant, and then positive r pointing down into the fourth quadrant. So if we want to go the opposite way, then we go negative 3.5. Okay, how else can we do this? So, yeah, do you have one through there? So here's 0, so she wants negative 4 pi over 3. And then? Positive 3.5. So notice here's the angle I'm showing, negative 4 pi over 3. Points you back into the second quadrant, so it'd be positive or negative? So this is negative 4 pi over 3. And I'm showing that angle right here. Negative 4 pi over 3 gives the direction of positive r, 3.5. Finally, so negative pi over 3. So if we just went as far as negative pi over 3, which would be here. Here's negative pi over 3. Makes positive r again, pointing into the fourth quadrant. And directly the opposite way would be our negative r. So it'd be negative 3.5 and negative pi over 3. Okay, questions? So my experience is when you start getting into functions, sketching functions, and doing harder things, that students will get tripped up because of just the basics of getting points. So that's why we spent so much time on this. Is it? So please ask if you're not clear on something. Don't hesitate to ask. Okay, so what about if we think about how do the Cartesian coordinates and polar coordinates relate to one another? this. So just go back in this. Just go back in the first quadrant here. So here's just any angle theta. Okay, right there. So this is any angle. Okay, so I'm not talking necessarily about 0.69 radians, but just this could just represent any angle. And so then this is any point right here. What would the so when we know that the polar coordinates are r comma theta, we know where that comes from now. Theta swept from positive x-axis, r distance from the pole. What about the x and y coordinates of that point? So x and y then is going to be, since this angle is the same as the trig angle, what will our x coordinate be? Right, so based on our definition of cosine, which is x coordinate and with a radius of r, this should be familiar, x equals r cosine theta, y equals r sine theta. So you can think of that as magnifying the definition of cosine as the x-coordinate, or you can think of this as the right triangle trig, because we know that adjacent over radius is cosine. Either way, they're both kind of the same thing. And then, but if we, so that would be how we would get x and y coordinates from polar coordinates. Okay, so these relationships always hold. So in the problems you do in the web work, if you've got problems that are dealing both with polar and like making a transition between polar and Cartesian coordinates, this is always true for all angles. So these are your tickets. You know, given something in polar coordinates, writing it in Cartesian coordinates. How about the other way around? If you had x and y, what would r be? So do you see you have a right triangle there? If this is r, so r would be equal to? By the Pythagorean theorem, square root of x squared plus y squared. Or another important relationship, r squared equals x squared plus y squared. Which is, what's that the equation of? Cartesian coordinates. Circle centered at the origin, radius r, which makes sense. So polar coordinate is based on circles centered at the origin, right? How could I write in polar coordinates the radius or the equation of this circle right here? What would I do? How would I write that equation of that circle? No, in polar coordinates. So what's true about the polar coordinates of all these points? R equals 3. Boom. Circle centered at the origin. R equals 3. All points such that R equals 3 for any angle will give you that circle centered at the origin. So that would be x squared plus y squared equals 9. Same circle. In Cartesian coordinates would be x squared plus y squared equals 9. But in polar coordinates, you just write R equals 3, and you get all the same points. Okay, and then if you wanted to write the angle, theta, that has to do with what? Y is the opposite side, x is the adjacent side, so that's tangent. So we'd have the arc tangent of y over x. So these are relationships that are transitionary relationships between x and y, the Cartesian plane, x and y coordinates, and r and theta coordinates. All right, so a big important thing in terms of understanding polar coordinates is be able to graph functions. So I'm gonna show you how to do that. Okay, ready. So the first one we want to do is, so when you have functions, I have this written somewhere else. functions, polar curves have the form r as a function of theta, which is in agreement with what we talked about. Theta comes first, right? Theta is like independent, and then based on theta, you're some distance from the pole. So your polar functions are this form. R, the dependent variable, is dependent on theta. So let me just show you a kind of a cool one here. 0. No, we don't need to do that. Okay, so we're going to do r equals 2 sine theta. Here's how you do these. What you do is you first sketch y equals 2 sine x on a different graph. And we're going to use that graph to help us draw the polar graph. So, can you sketch, if x is our angle measure and y is the vertical coordinate, can you sketch y equals 2 sine x? And if not, you're gonna have to review. But basically, so we can talk about the period, the max, the min, and the midline. So what's the period of 2 sine x? What's the period? When does that start over again? When does that complete a full cycle? 2 pi, right? So if you're not messing, if you just have the plain argument x, it's going to start over at 2 pi. Okay? What about the midline of just plain sine x? 0 is our midline. So our midline is at 0. And what about our max and min if it's 2 sine x? 2. So our max is 2, and our min is -2. And then we just got to remember what the sine does to start its cycle at 0. Does it start at the max, midline, or min? Midline, and goes up in the first quarters period. Back down to the midline at half a period. Min at 3/4 of a period. Back to the midline for a full period. And what's this doing? This is tracking, if we went around the circle in Cartesian coordinates, it's tracking the y coordinate of the point as you let the angle increase. So that's our y equals sine 2x. Now we're going to use this to sketch r equals 2 sine theta. And here's how we're going to do that. We're going to say as the angle, so we could put theta here. So rather than x, I think it's easier to do y and theta. Okay, so as the angle goes from 0 to pi over 2, what does r do? Increases from 0 to 2. Again, as the angle goes from 0 to pi over 2, this graph tells us that the radius goes from 0 to 2. So we imagine okay, so here's 0. So we're imagining the angle changing from 0 to pi over 2. And as we do that, the radius is going to increase from 0 to 2. So we'll do the first starting and end points. It's going to be 0 here, and then when we get to pi over 2, it's going to be 2. So imagine that radius increasing as the angle increases from 0 to 2. Can you imagine that? So starting at 0 here, and then we move further out away from the pole as the angle increases until we get to 2. So now I'll show the point. This is how we'll do this. Watch the point move. Go here. you see the point there? So there's the point at the origin. Unfortunately, I've drawn some other points there too. Here's the point at the origin, and then it moves out away from the origin as the angle increases to pi over 2. So that's something like this. So you imagine as this thing turns, getting greater and greater and greater. Oops. Too sharp of a turn there. There we go. Something like that. So that's r increasing as the angle increases from 0 to pi over 2. Then what happens in the next quarter period? We're at 2, from pi over 2 to pi. This graph tells us that r goes back to 0. And you see the symmetry to it. So now as we go in the next quadrant, as the angle turns from pi over 2 to pi, the radius is going to decrease back to 0. And in a symmetric way. You're going to have to do these without a calculator on the final. So make sure you know what you're doing. Don't just say, oh, I got my calculator. My calculator can do it. Okay, so now we're in the third quarter here. We're going to go from pi to 3 pi over 2. From pi to 3 pi over 2. What happens to r? What happens to r? Decreases to -2. So we're imagining the angle sweeping through the third quadrant, and what's happening? That radius is going to be in negative territory. So as I do, so from here to here, we're going to go from 0 to -2, which is on the red side of the line, right? On the red line. So what's going to happen? It's just going to repeat. Do you see that it just repeats what we had before in the first quadrant? So as we go from here, from pi to 3 pi over 2, we're in negative territory for r, from 0 to -2. And then in the fourth quadrant, so from 3 pi over 2 to 2 pi, it's going to be negative. It's going to start at -2. So it's going to start here at -2. And then it's going to head back to 0. All right, so really, even though the period of sine of 2 theta is 2 pi, for the polar graph, what's the period? Pi. It gives you a whole cycle of the graph for pi. So it doesn't always match up. Sometimes you need 2 periods of this graph to get the whole period, or 3 or something, or you know. But the period of this graph will not always match the period of that graph. In this case, the period of our polar graph is pi. Let me just show it being mapped out now. Here we go. Ready? Watch it. We said from 0 to pi over 2, r goes from 0 to 2, and then from pi over 2 to pi, the radius goes from 2 back down to 0. Then from pi to 3 pi over 2, watch it trace the same points, but in the negative r. And then from 3 pi over 2 to 2 pi, back from -2 to 0. Let me just show you something real quick. Ready? So watch. So what do you think? So what does that look like? Circle. It is a circle. Watch how it can be a circle. We know that r sine theta is y, right? So what if I multiply both sides by r? This will be cool. This will be worth staying for. All right, so if I multiply both sides by r, I've got r sine theta. What's that? 2y, right? Because that's r sine theta we said was y. And what's r squared? X squared, Pythagorean theorem, right? We said r squared is x squared for y squared. And so then we got x squared plus y squared minus 2y equals 0. Complete the square. How do you complete the square? You take half of the linear coefficient, and square it. So add 1. But I got to add 1 on the other side too. So we get x squared plus y minus 1 squared equals 1, which is the circle, center, 0, 1, radius, 1. That's exactly what this is. Center, 0, 1, radius, 1. Which one? Where did the what one come from?
When it goes from like equals 0 to equals 1.
If I add 1 on this side, I got to add 1 on this side too. I added 1 to complete the square. So if I add 1 on one side of the equation, I got to add 1 on the other side of the equation.
So the next step.
You've been doing it all your life. Adding the same thing to both sides of an equation.
What does it mean like to complete the square?
Okay, so yeah. So you get a perfect squared binomial. Y minus 1 squared.